In this tutorial, we're going to introduce you to the concepts of simple measurements, which is represented by buttons located on the left side panel of the screen, including the 2-point, 3-point, 2-line, and area tool. So we're going to pick a sample cine and go ahead and use some of these tools. So here we have a drop test where a device is being dropped from a certain distance at a certain angle. All right, so as we see, as it impacts, we see some deformation and we see a little bit of rotation. And we have some great tools to do some quick measurements. All right, so as before, the first thing we're going to do is go ahead and calibrate this video. Okay, notice in this particular video, we do not have a scale in sight. All right, so let's say, for example, we precisely know the edge length of this device. So what we can go ahead is we can calibrate off of that. So I'm going to go ahead and I'm going to select the edge here. So I'm going to hold down Control and I'm going to click the very edge, Control Enter, and then I go all the way across to the other side, and I'm going to go ahead and select the edge here. So I'm going to do Control and I'm going to walk it across here and then click Enter. All right. So let's say, for example, we know this is precisely 2 inches across. Select 2, go to OK. And now we know what our calibration is for this particular video. All right. So the first tool we have is the 2-point tool. So if, for example, this tool was used without any frame progression, we can click one side of the device and go all the way to the other side of the device, and we can get roughly what is the total length of that device, okay? And it is displayed right here. So this device is approximately 4.31 inches, and then we can do our sanity check again. We can click the sides of the device and make sure that we have an accurate calibration. So as you see, I click these 2 points, I get exactly 2 inches back for my current view. Now let's say, for example, we wanted to measure the approximate speed of this device as it's impacting. All right, so notice that we have 0 inches per second presented. That's because we didn't progress any frames. So what I'm going to have to do now is go ahead and select a very well-defined element on the device. This could be a marker, it could be a very distinguished speckle here. Here we'll go ahead and pick this speckle unit, and I'm going to go ahead and I'll click the very center of this unique location, and I'll left click it. All right, and then I'm going to right arrow forward in time right before the moment of impact, right about there. And then I'm going to go ahead and click Control, and I'm going to click down arrow, and I'm just going to find that same marker position, which is right here, and then click Enter. And if you notice here, now I can see that the distance between those 2 click points is around 0.15 inches. I clicked a delta of 16 frames, and I can see that this device is falling at 93.6 inches per second. All right, so really helpful in getting the speed of a subject as it's falling down. All right, a nice quick and dirty measurement. That's really what the 2-point tool is designed to do. The 3-point tool is helpful to get the angle. Now, if I wanted to know what is the angle of impact, assuming that this device is falling in the plane of focus and it is orthogonal to the camera, what I can do is I can go ahead and click on the edge of the device, okay? Then I can click the corner of the device here, and then I can click on this other corner of the device, and I can get the approximate angle of this device as it impacts. As you can see, I didn't do a great job getting this lined up, so this is not going to be accurate. So I can easily just go ahead and try again. So I'm going to click on roughly the same point there. All right, I'll use this edge, for example, here to keep it all straight. And I'm going to go ahead and use this opposite intersecting point here to get my angle. Okay, so this is telling me that this device is essentially falling at an angle of 87.85 degrees. That's the angle in between the two lines that I drew here. All right, so I can easily do some math to get that angle relative to the vertical direction if I wanted to. All right, I can even get, for example, if I wanted to get the angle of these lines, I can go ahead and click relative to the device, and then I can learn what is the angle of these lines relative to the edge of the device. So here I can see that this particular angle is around 53.36 degrees. Okay, and what's really cool is I can get the angular rate of the rotation using the 3-point tool. All right, this is really easy if you have a fixed axis. Here we do not have a fixed axis. A fixed axis would be, for example, looking at a fan blade rotating in time. All right, the best way to do this measurement is to use the 2-line tool. Okay, here what we can do is draw a line along the edge that is constantly falling here. Okay, and then we can progress it in time to a moment of interest, for example, in the future here, and get approximately the rotational rate along the edge. So we can see that the angle between these two lines is around 8 degrees. And we can see directly after impact, this thing is rotating on an average rotational rate around 1900 degrees per second. And I progressed 42 frames to observe that drop. All right, so this is a really powerful tool if you're looking for the change in angle of a subject that does not have a fixed axis of rotation, which is in this case, this cell phone is nice. Other applications include, for example, if you're looking at an airplane taking off and you want to get at what is the angular rate that is changing in time as it takes off. And then, for example, you can imagine like a boomerang or another subject that, again, is rotating but does not have a fixed axis in space. We have an area tool as well if you want to learn, for example, what is a calibrated area. So if I click once and then twice, you see that a box is formed here, and we can calculate what is the area in square pixels, which is the uncalibrated area, and then we have 1.5 square inches in this box. And we also will calculate what is the average pixel value in there. We essentially sum all the pixel values and then average it by the total number, which in this case we have around 978 counts inside this box. All right. Now you may look at this and say, if this is a 12-bit image, that does not look like 978 counts. Please note that this is the raw data being calculated. So if you were to go ahead and amplify or gain the image, it will not count in this average pixel value measurement here. Okay.
All right. The last thing we're going to do is go ahead and export all the data that we just collected. Notice that we use a mix of different tools. We use every single simple measurement tool we had in the arsenal here. And conveniently, that is all been saved in the background. All we're going to do is click export. And we're going to go ahead and save this data as a CSV file. So let's call it simple measurement tools. All right. And that should have automatically saved all the data to a CSV file. Okay, so let's go ahead and navigate to that file. So we just opened up this file, and what we can see here is that we have the date recorded, we have the name of the Cine file that we processed, and what we have is we have each tool defined here that was used. And you can take a look that we have a calibration feature which was used called the scale tool, and you can see that it even captured the scale and the known length that was inputted here. We used the 2-point tool 3 different times. We used the 3-point tool 4 different times. We used the 2-line tool once, the area tool once, and it's all been recorded in this CSV file that's readily accessible through any other platform for post-analysis.
So this is a look at some of the simple measurement tools. I hope you guys learned something in this tutorial. and looking forward to the next one. Thank you.